Today I'm going to discuss the results of two Barley Max trials. The first trial I'll cover compares the optimum rate of nitrogen for newer malt barley varieties against an old standard. The second trial I'll discuss compares the performance of these same barley varieties to other inputs such as seed treatment, foliar fungicide, and plant growth regulators. Both trials I'll be discussing were put forth by Mitch Japp, who's now with SAS Barley, and Shannon Chant with the Ministry. The project received funding from the Ministry's Strategic Field Program. So let's get started. Do newer malt barley varieties require more nitrogen? Have you ever noticed that high-yielding wheat varieties tend to have lower grain protein? While this is not desirable for a hard red spring variety destined for human consumption, it is desirable for grains destined for alcohol production, like ethanol wheat or malt barley. Less protein means more starch to turn into alcohol. Some of the newer malt barley varieties are much higher yielding than the old standby AC Metcalf. This made us wonder if high-yielding varieties of malt barley had lower grain protein than AC Metcalf, and if so, would the most economic rate of nitrogen be higher for these varieties? 4 Agri-ARM sites participated in this first study. They included Yorkton, Prince Albert, Melfort, and Swift Current. The trial was conducted in 2020 and 2021, and as you know, widespread drought occurred in 2021. These are the yield results from 2021. When averaged across all locations, you can see barley yields are quite low and unresponsive to added nitrogen for all 3 of the malt barley varieties tested. Note that the nitrogen scale at the bottom includes background soil nitrogen, which on average across locations was 70 pounds of nitrogen per acre. The varieties being tested include AC Metcalf in blue, which is an old variety but is still popular amongst maltsters. However, it is a relatively low-yielding variety and doesn't have the best leaf disease package. CDC Bow and AAC Synergy are newer, higher-yielding varieties. Synergy is typically the highest yielding variety and is now the check in the regional variety trials. However, during the drought of 2021, we really didn't see any yield differences between varieties or any responsiveness to added nitrogen. Low yields were not the only problem during the drought. Protein levels were through the roof. When no additional nitrogen was applied, protein was already above 13%. Depending on the maltster, protein should be in the range of 10 to 13%. So growing malt was a bust for us in 2021. With high protein and unresponsive yields to added nitrogen, the most economic rate of nitrogen for each variety could not be determined. However, the protein level for AC Metcalf was consistently higher compared to the newer varieties, suggesting nitrogen rates can be pushed higher for Synergy and Bow before an acceptable grain protein for malt would be exceeded. In 2020, we were able to compare the optimum rate of nitrogen between varieties because barley yields were responsive to increasing nitrogen and protein levels generally fell within an acceptable range for malt. While we struggled to get average yields much higher than 40 bushels per acre in 2021, you can see here that barley yields are much higher and quite responsive to added nitrogen in 2020. In this year, the background soil level of nitrogen was 55 pounds per acre on average. You can see Synergy in orange is higher yielding and more responsive to added nitrogen than Metcalf in blue. CDC Bow is in between in gray. Not surprisingly, grain proteins were much lower in 2020 because of the high yield potential. The protein of AC Metcalf in blue is higher and more responsive to added nitrogen compared to the higher yielding varieties Synergy in orange and Bow in gray. This is what I was anticipating because it means the lower yielding Metcalf is going to be rejected for malt based on high protein at a lower rate of applied nitrogen compared to the other higher yielding varieties. For the sake of simplicity, let's just compare Metcalf and Synergy. If we consider 12.5% grain protein to be the maximum level acceptable for malt, then Metcalf reaches this level at 115 pounds of soil plus fertilizer N, and Synergy attains this at 150 pounds per acre. Remember the background level of soil nitrogen is 55 pounds per acre. So maximum rates of applied fertilizer are 60 pounds of nitrogen per acre for Metcalf and 95 pounds of nitrogen per acre for Synergy. Rates higher than these will lead to protein levels in the rejection area. If we were to fertilize both varieties at the maximum safe rate of nitrogen for Metcalf, Synergy would generate 8 bushels per acre more yield than Metcalf. Assuming the price per bushel received for both varieties is the same, Synergy is going to be the most economical variety. But if you recall, we can still push the yield of Synergy more with rates of soil plus fertilizer nitrogen up to 150 pounds per acre before the 12.5% protein limit is exceeded. At this nitrogen rate, the yield of Synergy has been increased by almost another 7 bushels per acre, but we've also spent more money on nitrogen. So how does this all work out economically? Well, it depends on what prices you want to use for malt grain and nitrogen. There's been a lot of volatility in the market, so I'm going to give you 2 scenarios. The Saskatchewan Crop Planning Guide in 2021 was using $5.20 per bushel for malt and about 50 cents per pound of nitrogen. If we use these values, the most profitable rate of nitrogen, without going over the 12.5% protein, is at the maximum allowable limits of 115 and 150 pounds of soil plus applied fertilizer N for Metcalf and Synergy, respectively. Again, since we have 55 pounds of nitrogen per acre in the soil, this equates to an optimum rate of applied nitrogen of 60 pounds per acre for Metcalf and 95 pounds per acre for AAC Synergy. At these rates, the gross returns minus the cost of the nitrogen is $429 per acre for Synergy and $368 per acre for Metcalf. So in this example, Synergy required 35 pounds of nitrogen more per acre and generated $61 per acre more income than AC Metcalf. If we had fertilized both varieties at the maximum allowable nitrogen rate for Metcalf, then Synergy would only have generated $44 per acre more income instead of the $61 per acre. Discussion changes a bit if we use a higher price point for malt of $6.11 per bushel and a much higher nitrogen cost of $1.25 per pound. These are the values used in the 2022 Crop Planner. When changing to these price points, the most economic rates of nitrogen for Metcalf and Synergy decrease a fair bit because of the relatively greater price increase for nitrogen relative to malt. For Metcalf, the economic rate of applied nitrogen has dropped from 60 to 42 pounds per acre, and for Synergy the rate has dropped from 95 to 69 pounds of nitrogen per acre. In this example, Synergy only requires 27 pounds of nitrogen per acre more than Metcalf, which is less than 35 pounds of nitrogen per acre in the previous example. While gross returns minus nitrogen costs are a little higher for both varieties in this example, the economic benefit of growing Synergy has declined from $61 per acre in the previous scenario to $50 per acre in this scenario. At the end of the day, price points are going to change the most economic rates of nitrogen for each variety, but as long as the price for Synergy and Metcalf are the same, Synergy will require more nitrogen. Conclusions. We should be applying more nitrogen to Synergy relative to Metcalf because the yield of Synergy was more responsive to added nitrogen, and Synergy yields can be pushed a little further with higher rates of nitrogen before protein becomes unacceptable for malt. But should we be applying 27 to 35 pounds of nitrogen per acre more, as this study would suggest? Well, I'm not overly comfortable with that because it seems like a lot and this is just one study. However, if you're a grower switching from Metcalf to Synergy, you might want to consider experimenting with applying a little bit more nitrogen. Let's switch gears now and see if the requirements of other inputs vary between old and new varieties of malt barley. We have 2 years of data from 2020 and 2021, and there's still one more year to go in the study. In each year, trials were conducted at 5 agri-ARM sites, which were Yorkton, Melfort, Prince Albert, Scott, and Swift Current. Trials were set up as factorials, with 3 malt barley varieties being tested under 7 different levels of management. This creates 21 treatments, which were replicated 4 times. The varieties tested were AC Metcalf, AAC Synergy, and CDC Bow. Metcalf is still popular amongst maltsters, but it's an older, lower-yielding variety with a poorer disease package than the newer varieties Synergy and Bow, which are varieties gaining popularity. As we move from management level A to G, the level of inputs generally increases. Management A starts with a low seeding rate and a low rate of nitrogen and phosphorus. As we progress through the management levels, seeding rate is increased, nitrogen, phosphorus, and potassium are increased, seed treatment is added, fungicide for fusarium head blight is applied, a plant growth regulator is used, and finally fungicide is applied at flag leaf. Unfortunately, each one of these factors is not evaluated in isolation because this would make the trial ridiculously large. Also note that the nitrogen rate includes what is in the soil plus added fertilizer, whereas the P and K rates are only just what was applied. The plant growth regulator was Modus. Trivapro A and B were sprayed at flag to control leaf diseases, and Caramba was sprayed for fusarium head blight control. When analyzing the data, I decided to separate the data into high and low yielding site years. There was a lot of yield variability, and I was curious to see if the responses to inputs differed between the high and low yielding groups. This is a list of the high yielding site years. You can see average yields vary from 62 to 100 bushels per acre, and grain protein varies from 10 to 12.4%, which is all acceptable for malt. Here are the low yielding site years, which are mostly from 2021, when drought was widespread. My site is the Yorkton site, which was blessed with drought both in 2020 and 2021. In this group, yields range from 17 to 43 bushels per acre, and grain proteins vary from 15 to 17.1%. Low yields caused by drought means high protein, and none of these protein levels are acceptable for malt. So on average, the high-yielding group yielded 78 bushels per acre of grain with 11% protein. In contrast, the low-yielding group only averaged 31 bushels per acre of grain with 16% protein. Here we have the average yield of varieties from the high and low-yielding site years. Each value is averaged over management level because there are no significant interactions. In other words, the effect of management was the same regardless of variety. For both the low and high yielding groups, AAC Synergy was significantly higher yielding than both AC Metcalf and CDC Bow. While Synergy was 10% higher yielding than Metcalf for the low yielding group, it was only 3% higher yielding for the high yielding group. Usually we find Synergy to be 10 to 15% higher yielding than Metcalf, so the small difference in this study was a surprise to me. On each bar, I've posted the associated grain protein for that variety. There are no statistics available for the protein numbers because the values were taken from a single treatment sample which was bulked over 4 reps. However, you see there is little variability in protein between the high-yielding varieties. Not too surprising since the yield didn't differ much between the varieties. For the low-yielding varieties, Metcalf had higher protein, which could be related to lower yield, but then we would also expect CDC Bow to have a higher protein too, but we don't. Anyway, let's move on to the effects of management. Here is the effect of management on barley yield averaged over variety for the high-yielding group. The protein levels are in the little white boxes, and they don't vary much between treatments. All protein levels are easily acceptable for malt regardless of management, so let's just remove them from the picture. To work out what barley yield was and wasn't responding to, we need to make some specific comparisons. Comparing management B with C shows us there was no response to seed treatment. I'm not surprised, even with the high-yielding group, because conditions were just not conducive to seedling-borne disease in either year. A comparison between D and E shows a significant yield increase in response to increasing nitrogen from 90 to 120 kilograms per hectare. Again, these rates include the residual soil nitrogen. A comparison between C and E suggests no yield response to fusarium head blight fungicide. Not surprising, weather conditions generally have not been conducive for Fusarium head blight infection at heading. A comparison between E and F shows no yield response to plant growth regulator. Lodging just wasn't a significant issue for any of the site years. A comparison between F and G shows the additional application of fungicide at flag did not affect yield. In summary, we have determined there were no yield responses to seed treatment, plant growth regulator, fungicide for Fusarium head blight control, or additional fungicide at flag. So let's just take these factors out of the comparison and see what else we can determine. A comparison between A and D now reveals some combination of increasing seeding rate, increasing P, or adding K has significantly increased yield. Unfortunately, the trial design doesn't allow for a determination between these inputs. So everything that barley yield is responding to can be summarized by a comparison between A and B. Yield is increasing in response to increasing nitrogen and some combination of increasing seeding rate, phosphorus rate, and added potassium. Yield did not respond to seed treatment, PGR, fungicide for Fusarium head blight, or additional fungicide at flag. Let's face it, conditions have not been overly moist the last 2 years, which is not conducive for lodging or disease development. Let's see what happened at the low-yielding site years. Here are the results for the low-yielding group on the same scale that was used for the high-yielding group. On average, the low-yielding site years only produced 31 bushels per acre of barley grain with 16% protein. Here's the high-yielding site years again for comparison, with 78 bushels per acre of grain at 11% protein. Here's the low-yielding group again, but I've cut the scale in half to 50 bushels to make differences more apparent. I've also included the grain proteins in boxes. You can see protein varies a bit from 15.2 to 16.6%, but who cares? They're all way too high for malt, regardless of the management. So let's just remove them. Interpreting the results from the low-yielding site years is a little less straightforward than it was for the high-yielding group. The problem lies in that the yield for management C was unexpectedly low. When managements B and C are compared, it appears yield is decreasing in response to seed treatment. However, I don't think this is real, since management D and E are also seed treated and don't significantly differ from B. When C and E are compared, it looks like there's been a response to Fusarium head blight fungicide. However, I don't believe this is real either, particularly since Fusarium head blight or heavy leaf disease has not been prevalent over the last couple of years. Again, the problem is an oddly low yield for management C. I do think this negative yield response to PGR may be an issue. Anecdotally, I have heard of some field-scale issues when PGR was applied during last year's extreme drought. There really isn't a reason to shorten your crop during drought. Management G also received PGR, and it is also significantly lower yielding than E. Moving on, there was no yield response to increasing nitrogen detected for the low-yielding group, which makes sense because of the low yield potential. There was also no response to additional fungicide at flag because of the dry conditions and low disease pressure. Numerically, management A with the lowest level of all inputs yielded the most, which I think says it all. There were no positive yield effects from increasing management, and PGR may have actually had detrimental effects under severe drought. So the conclusions from this study certainly won't be appealing to retailers. Conditions have been dry and yields were unresponsive to fungicide and PGR. There just wasn't much disease or lodging. However, we have one more year left in the study. Maybe it'll be wetter.